Hey everyone, Zach, congrats on the first. Eldritch, you've missed out just narrowly so many times. That sucks. Are you supposed to resort your ties? Where are you getting first? Yeah. Zach is far too busy sorting all those ties. Okay, let me... I think today is the exciting day that we're going to start on chapter 5. Finally, I spent way too long on chapter 4. I read it a bit last night. Well, I read all of it. I don't know if I absorbed all of it, though. So chapter 5 is on energy. It defines what work is. Some of this stuff was definitely new to me. Like the work energy theorem. Like, I didn't know that work is equal to delta K. I knew that work was equal to, like, potential energy, or I guess delta U, but not also delta K. But I guess that is a conservation of energy thing. Yeah, okay, I guess that... Okay, you know what? I'm glad I tried to explain that out loud, because... if work is equal to delta U, it should also be equal to delta K. And they give a different version of it. Wait, yes, that's the work energy theorem. Just that. And then there's also the work energy theorem in general, which seems a little bit confusing to say the difference between them. Or, like, you know, it feels like one should be the primary one, but I don't even know which one they mean. I guess it's probably this one. Well, okay, yeah, W equals delta K for an object that is rigid. If it deforms, you have to consider whatever heat energy you're creating by deforming the object. And it doesn't have to be heat. It could be like it has a spring inside of it or something too. I think. Yeah. They say this delta E internal includes heat, but it's not exclusive to heat. Yeah, and they say, okay, yeah. Do I have a Rubik's Cube? Always. Alright, so this definition of a conservative force, it feels almost backwards to me, where I think... Oh, you want a Rubik's Cube solve? Alright, let me just get this thought out. Where I'm just thinking about, like, the E and M that I was doing. We were talking about work as taking a positive test charge, and some external force is doing work to bring it closer to an actual charge. But this is talking about, like, that positive charge itself, it seems like, which I think should be the same thing. I just need to expand my thinking that if the external force was doing positive work to bring the test charge in, then the positive charge itself was doing negative work. But it's otherwise kind of like the same thing. Let's get this solvent. Just scrambling it right now. Hey, Mood Hood? Or Mood Hood? Welcome in. Your name defies all pronunciation rules. I hate that Mood is pronounced that way and that Hood is pronounced, like, they're spelled the same, but they're pronounced different. Either way, welcome in. All right, let's inspect it. Oh my god. Oh god, I'm choking. I can't find the pieces that I need. Uh, G-perm. I think it's this one. It's not. I messed up. Oh no, this is gonna be a terrible solve. I messed up a freaking G-perm, dude. R-perm this time. Terrible solve. But there you go. What do you call someone who plays a Rubik's Cube? A cuber. Yeah, that's a real thing. When I was in high school, actually, I went to, I think, 2 Rubik's Cube, like, cubing competitions. I had only just learned how to solve them, so I did terribly because, like, I think we were, like, maybe 16 or 17-year-olds, and everyone, like, my friend group and I were, like, maybe we were 15 or 16. And everyone else there were, like, 10-year-old kids who were, like, cracked. So I did terribly. I would have done a good bit better now, that I know the better algorithms, but yeah. You click, I didn't even finish my second thing. Oh. Yeah, that's all could have been a lot better though. A couple of the algorithms I'm rusty on, so I messed up a piece of that. Okay, so then potential energy is equal to negative work. Or sorry, change in potential energy. They make a point of saying that we don't care about potential energy itself, just care about the changes in potential energy. Oh my god, I didn't even think about it yet when I was reading this, but I have encountered this exact formula before in E&M with E's equal to negative del phi. Do you call Rubik's Cube that can solve itself? A self-fulfilling prophecy. I guess so, yeah. Are Rubik's Cubes a prophecy? All right, this is a really strange equation for velocity. I have a hard time figuring out when this would be helpful, but I assume it'll be helpful. There'll be at least one problem about it, I imagine. They have this cool visualization of potential energy versus starting position. And so if you chose, say, well, wait, how are they explaining it? Why are they choosing E and figuring out what X is? I feel like we should be, I mean, How does Rubik's Cube give directions? Turn left, twist right, repeat. Oh god, those would be confusing directions. So for some reason they're choosing vertical axis values, but potential energy, and figuring out what X would be, which, okay. I think that they do that probably on purpose because you need to choose the initial energy level, and then probably for the purposes of the visualization, they do this because I think they're saying depending on the initial energy level that you choose, you can literally imagine the object. You can imagine this like graph as a hill, and the object is rolling along the hill. So if your initial energy level is E2, your ball is going to, like, you know, it could start, I guess, on either place where it intersects, but either way, it's going to just like go down the hill, come back up to that same point, and then go back down the hill and just like oscillate back and forth. If you choose E1, it's just stuck at the bottom of that valley there. In the case of E3, it could be stuck in either of these two valleys, depending on like the starting conditions, but it'll just be stuck in one of them. And I guess if you choose E4, it'll go through the entire thing. Back and forth. Why did the Rubik's Cube become a convenient? It had a twisty sense of humor. Oh my god, these are real stretches, but I'll allow them. To give this advice for solving more complicated energy problems, like 5.9, to set up a more kind of don't know who sent the anonymous, but thanks. Yeah. What did the colorblind say to the Rubik's Cube? Fuck this. So you need one of the Rubik's Cubes with like pictures on each side. Okay. Let's get into some actual problems here. I'm going to skip multiple choice problems for now because I kind of wish maybe the person said this in the intro for the book, but these foundational problems, like all the other multiple choice problems and the problems after, rely on these foundational ones. So you really want to start with these, despite them not coming first. So let's start with number 1 here. Force from a given spring is given by Hooke's law. F equals minus kx. Calculate the work done by the spring going from x1 to x2. Okay, so if there's one email and attached a photo, it's 93 by 93 Rubik's Cube. I don't think it's a cube anymore. 93 by 93 they haven't made, but I do own a 7 by 7 cube. And they do go bigger than that. And mine goes high, it's like 13 by 13 or something. I don't quite remember though. They don't really get any harder, they just get more tedious, to be honest. So even the 7 by 7 is way overkill. It's too much. Calculate the work done. Okay, so work is equal to the integral. For this, we can just do f dx and not have to question the directions too much. Kid asks to a master of cube, what can you do? Yes, it's gonna be master answers. 43, oh god. Probably like pentillion, 252 quadrillion. No, I might have been right. That might be. I'm not going to count all that, but I think it's a number of possible states of a Rubik's cube. That seems like it, at least. Why is the pen supposed to be this thick, by the way? I feel like this isn't very readable. Maybe it's more readable, but this. I don't know what shows up better on stream. To my eyes, I prefer the medium pen, but I think at some point I changed it to the thick one, but this seems way too thick now. I don't know why it seems thicker than usual. I think I'm gonna go with the medium stroke unless I hear a complaint just now. Thinner looks better? Okay. And that settles it. Thank you, Peach Tea. Oh, shoot. This thing is lagging. I think I need to kill the process that's conflicting with this. There's some annoying Logitech driver that interferes with my tablet. And if I don't go into Task Manager and kill that process, then it makes weird lag. Thick looks nice for the diagrams, though. Okay, that's good to know. Wait. Why is it so thin now? I didn't change the... Oh. I get it. Okay, no, that Logitech driver messes with the thickness. That's why it looks so much thicker. Oh my god. Okay, let me... So I wasn't getting... Okay, that's what the medium looks like. Okay, maybe I do want the thick then, because the driver makes the tablet think I'm pressing as hard as possible, which is why it looks so much thicker than usual. But this is the normal thick marker, and I think maybe this is probably better, because that's about what the medium was. This works now? Okay. This is a terrible looking spring, by the way. Okay, and so f is a function of x here. So can we just... Do we need to do anything more than just integrating this? In terms of everything looking more normal? Okay, awesome. I feel like we can just do this. And we'll get that after plugging in the bounds. I think I have another Rubik's Cube joke in the mail, so we're ending today's episode. All right, Eldritch. Fair enough. We can also bring the negative sign inside the parentheses. So, does this thing make sense? It looks a lot like kinetic energy, except with position. Hey, Mohammed, I remember you. It's been a minute, but I do remember you. Okay, so does this make sense? So if I, hey, Phobos, how's it going? Yeah, Mom, I remember you were being super extra and I called you extra. Okay, so if x1 is greater than x2, I'm getting negative work. Does that make sense? Calculate the work done by the spring. I'm the extra mince. Yeah, you sure are. Welcome in though. It is good to have you again. Okay, so I'm getting confused. We're like, if you have a spring, well, what is a spring's like natural state? It's like not completely uncoiled. It's not completely like, it's not completely super closely coiled like that, where it almost looks like a cylinder. It's like somewhere between that and like super stretched out. Which, and I'm thinking about this because you could either compress it and get oscillations, or you could expand it and also get oscillations, right? And I'm wondering how we differentiate between these. Or like, I'm trying to make sure I'm covered in every scenario with the formula that I've written here. Because, well, in either case, anytime you move away from the spring's resting position, the spring is doing negative work. And when the spring is moving the mass towards the resting position, the spring is doing positive work, right? I think that's how that works. Yeah. And so if the starting position these being squared is interesting. Because we're ignoring signs. I assume we're taking the origin as the resting position. So what happens if that's 0? What happens if we go from x1 here to this x2? x1 is a smaller numeric value than x2. What's my real name? My real name is Don. And so the string is being stretched out in this case, and the spring is doing negative work because we're stretching it further beyond where the spring wants the mass to be. So, and we do get a negative value if x1 is smaller than x2. So that checks out. The same if we reverse these two things. Okay. So now if x2 is here, and let's exaggerate it. If x1 is way over here, x1 is a big negative value, x2 is a relatively small positive value. We're getting overall that we're getting positive work. And I think that also makes sense because the spring spends, like a tongue twister, more time restoring the mass to the resting position than it spends being stretched beyond the resting position. All right, see you, Mohammed. Thanks for saying hi. So if x1 and x2 are over here, x1 is bigger but negative, x2 is smaller and also negative. We get positive work, and that's a good thing. Okay, so I think I'm comfortable with my answer then. Maybe we can go and check the book's answer. I think that this checks out. Try not to look at any other solutions. Okay. I got the equation right, it looks like. That's actually in a spring. If you drive the mass movement at a constant speed, your force exactly cancels the spring force, so your force equals plus kx. The work you do is therefore exactly opposite to the work the spring does. Right. Okay. Cool. I'm happy with that then. I said bye to you too, Muhammad. Oh my god. This is why I'm saying you're being extra. I literally said bye to you and you're like guilting me now. Like, god damn it. Fucking hell. Okay. What's up with the work energy theorem? The exception object A can be written as V dV dx. Really? Then combine the equals I made to prove the work energy theorem. Okay, so the equation version of that last statement is, W equals delta K. This A equals V dV dx thing is interesting. Is there any... My instinct is to look at this, like do a separation of variables like you do with the differential equation. I think I don't quite like how I don't quite like where I'm going with this. I'd rather integrate each other with respect to x. This just feels a bit cleaner to me. Is A a function of x though? It can be. Maybe this isn't so clear to me then. Is it maybe a chain rule thing instead? Because I don't quite know what to do with the left side of the equation here. Maybe I'll leave that up. We definitely know that A is dv dt, right? And I assume we can write dv dt as dv dx dx. Oh, okay. dx dt is just a v. That's way simpler. That's what I was trying to think of too, Phobos. But the lack of time in this equation was like giving me pause there. I think it's what I just wrote on the right side. So we start with A equals dv dt. That's something we can hopefully all agree to. And by the chain rule, dv dt is equal to dv dx times dx dt. Which I feel like I should really learn theoretically why this is okay to do. I just do it the intuitive way of knowing that these dx's can cancel and you think of it as dv dt. But I don't know why that's theoretically okay. That'll be subject for another time though. And then from here, you notice that dx dt is just v. Okay. That's part one of that done. F equals MA. Wait, I miswrote that. dv dx. A of x of t. Right. It's that I don't. I just wasn't quite sure where to go with that. I guess I don't know. Um, I think we multiply both sides of this equation through by m. Um, and we know that f equals ma, so f equals mv. And now I assume we integrate with respect to x. Let me I'm crowding my work for no reason. You can maybe make some argument like that, but like I don't know, I was getting lost in the weeds of like what that a would look like. Like if it's like a spring, we could definitely say that a is some function of x. I guess it would be like that. But if it's not a spring, I don't know exactly how that works. I'm sure you can always express it as a function of x. I don't know, I was getting like lost in the weeds of the specifics, which is why I kind of abandoned that thought line or like line of thought. And I think we want to integrate with respect to x here. And I guess we can integrate from v1 to v2. The first one we know, I guess that'd be x1 to x2. I don't think that matters, because either way, we're going to call it w. And that's just delta k. Okay, I think we did it. Let's look at the answer. So number 2. Okay, so the book does give the same argument as I did. Okay, so they do the bounds. They do. Okay, nice. I think we nailed it. Good, number 3. This is a nice way to build confidence before it gets beaten back down by the later problems. Find the gravitational potential energy of a mass m as a function of y, with upward taking to be positive, measured relative to a given point chosen as y equals 0. I feel like B is just number 1 with x1 equals 0. Let's think about A first, though. I know what the result should be. Let's see if we can actually get it. You know, it should be mgy. So upwards is positive. Um, So, you know, I'm trying to think about our signs here. It's W equals negative F. No, it's just W equals integral f dx. Okay. I guess we're doing dy. From 0 to y. And the force due to gravity. So the force due to gravity would be negative mg. But I think we're taking the external force that is opposing gravity. So we're going to call it positive mg. And this just gets us mgy. I think that's how that logic would work. In part B, I think we're doing more or less the same thing. The integral from 0 to x f dx, and I think we're also, F is normally minus kx for a spring, but we're talking about the external force opposing the spring, I think. So we're taking positive kx. Because when the spring is stretched out, I think we want to say it has positive potential energy. Or compressed. Let's see if that's right. Wait, minus gy? Oh, wait, no. That's the work done by gravity. Oh. Okay, so I skipped the step in the logic. You do find the work done by gravity, and then use the definition delta U is equal to minus work. Okay, and so I made the same mistake with the spring, but that's a mistake I can live with. I just kind of jumped the gun on that. Okay. Number 4. Different frames. Are we flirting with relativity here? Let's see. Oh, I need to X out of that sidebar, right? And expand that. There we go. Sorry if someone's having a hard time reading that. An object of mass m is initially at rest, and then a force is applied to it cause it to undergo a constant rate acceleration a for a time t. Calculate the work done on the object and also the change in kinetic energy. Interesting. So I believe from chapter 1 or 2, we have the equation vf squared minus vi squared equals 2a, and they said, I guess d. That's going to become our x, because we can call our starting point x equals 0. we're also at rest initially. So I think this equation becomes bf squared equals 2ax. And I assume this is going to be helpful at some point, because is it helpful actually? What I want to use work equals integral of force dx. We're given an acceleration for a period of time though. We're not given x's. I guess we can still call that vf squared. I wonder if we actually want the equation x equals vt plus a half at squared. Well, it's v not t, right? Which is 0. I assume that's, I mean, can we, so we know F equals MA. Oops. A is constant. And x goes from 0 to 1/2 at squared. So this equation is going to become 1/2 ma squared t squared. Acceleration times yeah, Phobos. That's kind of initial. V naught is 0. I guess V does equal AT. Okay. That's part I didn't feel comfortable about, but I think we can comfortably call a squared t squared v squared, and that will be perfect. Yeah. Because delta k is a lot simpler to get. 1/2 mv squared minus, I mean, I don't know why I'm even writing that, but delta k is just by definition. Okay, I think we're good for part A then. What about for part B? Repeat the same task, but now by working in the reference frame, moving to the left with constant speed v. Only the object starts with speed v instead of starting at rest. Wait. I could just take the part in parentheses and run with it, but I'm trying to figure out what this reference frame, how the reference frame is equivalent to that. Oh, okay. I was getting mixed up, I think. the v they're using in part B isn't the same final velocity that I was using in my work. That v in part B I think is completely arbitrary and doesn't necessarily match the final velocity. And so, wait, it's moving to the left with constant. Okay, I just want to draw this out. The block is right there. Our reference frame, we don't need a y-axis, but is moving to the left with speed v. So if we are inside this frame, it feels like we're at rest and the block is moving to the right with speed v. But then it also undergoes acceleration a, and that's how that works. Okay. And so it does come out to be the same as just having an initial starting velocity, which is interesting that they give this kind of reference frame interpretation. This isn't math. It involves math, at least. Everyone knows there's no letters in math. True. Not a single one. I know kinetic potential energy right now. Jinx. Do I owe you a Coke? Okay, so maybe let's start with delta K here, because that's just a lot more direct. So 1/2 m, I guess I'm going to call it VF squared minus 1/2 m just V squared to match the V in the problem. Now work is the tricky bit. We're going to hope whatever we get for work matches this bad boy up here. We just covered EK equals 1/2 mv squared. Oh, nice. Yeah, that's what I've just like started on now. What are the bounds? We're still starting from 0 with respect to x, right? And so it's really this equation that changes. It's going to be Vt plus 1/2 AT squared. Unfortunately. I'm not laughing. Why the fuck are you copying me? You're right. That's my bad. This is a serious issue. Really, Central, I just copy everything that you do. Scripted? Yeah. You know, yeah, I started playing DayZ only because of you. I do this math only because you're doing math and physics. I cook because you cook. Everything. You don't exactly, yeah. I traveled forward in time to see what you were doing, and I copied it down, and I I travel back so I could do it first and pretend like I'm not copying, but you caught me. It is all just me copying you. Um, okay, well, what the hell do we do with MAVT? That's our one half, or the other thing is our one half MVF squared. That is what we wanted. We have to hope that this term over here is by some crazy coincidence equal to this term here. So we need a sign flip somewhere in here. Next time you go forward in time, bring me back a t-shirt. That's all you want? From someone who could travel forward in time, you just want a t-shirt? Not like a Back to the Future, like sports almanac? So you can place some bets. I guess we know that V is, or VF is equal to V plus AT. So we could rearrange, ooh, or do you want to keep that? No, I think we want to, no. What do we want to do? We could say that AT is equal to VF minus V and plug it in for that AT. What does that look like? It doesn't get us the one half that we need. So I want to say my friend traveled in time and I got this lousy t-shirt. That's pretty funny. uh, I am pretty funny. I don't know about that. You have your moments like every once in a blue moon. There are two words people describe me as: pretty and funny. Like, yeah, is that it? Shut up and get back to work. Yeah, you're right. I'm just all over the place. I was talking to myself. Yeah, you do make great conversation. I can understand why you'd want to talk to yourself. I didn't even do that right. I had to take the A away also. Oh, do I maybe want the other equation? Do I actually want... I need to get rid of the T somehow, though. I was wondering if I actually want that equation. I guess we could say... Oh my god, dude. VF squared minus V squared equals 2A times 1 half AT squared? There's no way that's what I'm supposed to do. Educate laws of energy accounting balance. Holding on to a lot of potential energy over here, fat bastard. K-bye. I mean, you don't have the potential energy until you're elevated, though. You know, that's the issue. You are going to get a lot of it thanks to your mass. It's a joke. Don't think too hard. Thinking hard is the only thing I have, though. Could be elastic potential. uh. Or maybe you have your own gravity field. That would give potential energy. I don't think the stuff I just did is the play. Wait, maybe it is the play. I forgot there's a V there. I just wasn't doing it right. No, I'm just playing off the joke that you said, Central. That's all I'm doing. um, is this something? Hey, oh gosh. Elias, or Elias? A work paper about Euler's identity. I'm focusing on the math, complex intervals, and Fourier analysis. Any ideas for other topics to include? The paper is supposed to be 15 to 20 pages long. Yeah, just talking about Euler's identity in general. Actually, you might already be including it in your Fourier analysis. Euler now identifies as a penguin. Oh my god. That, you know, that is an identity for Euler, but all right, see essential. 15 to 20 pages? Oh my god. Okay, I mean, the thing that comes to mind for me immediately is and this might be included in your Fourier analysis already, but potentially, but it's helpful in getting solutions to second order differential equations. And so this is an E&M book, but it does this example. If you have an AC circuit with an inductor, a capacitor, and a resistor, and a battery, if you actually want this book, I can send it to you. It's pretty freaking difficult, but I can send it to you if you want it. You end up with a second order differential equation because there's a relationship derivative q equals I with respect to time. That'll be perfect. Okay. You actually want it? All right, I'll send it to you right now. And so even like right here, you can say they're setting Euler's identity, and this is a differential equation with real numbers. You can use complex variables to solve it though, and it goes for any second order differential equation as far as I know. And the reason that it works is all because of Euler's identity. Let me send this PDF to Central. I can send it to you too if you want, but is this the actual? Oh no, it's too big. Okay, and it's probably still really. Why is that too big? It's probably still pinned in my reading group channel. Oh, it is. Okay. Let me. Oh no. Copy message link. Okay. You found it? Okay. Oh, Oliver, hey, how's it going? Dude, it was so awesome to run with you. God, I'm stuttering. I'm sorry. I just wish I peeked in such a stupid way. Like I saw they had spotted me, and then I peeked it again, and they sniped me. But either way, it was great to meet you yesterday. And so at least if you want this book too, I mean, it has way more information than you probably need, but if you do join my Discord, down here in the reading group channel, you can check the pins, and it's in the pinned message right there. And by the way, for anyone who doesn't know, I was playing Daisy yesterday, and I happened to run into Oliver there. He streams also, so if you like Daisy, you should check him out. The messages seem important. Yeah, what is it gonna be? I'm not a nerd. I don't want this. I mean, thank you. And so at least if you want the book too and you didn't catch that, just let me know. But can you leave now? I mean, hey, you're the one who said you wanted the PDF. You leave whenever you want. Are you hopping on to today too, Oliver? Divyansh, I'm sorry I missed your message. Which subject did I major in? I majored in applied math. You're so clingy. I am. Yep. Oh, nice. Good luck with it. I'm probably not going to be able to, but hope you have fun. Gonna join the queue now. Oh dang, yeah, you're just a little bit late for the restart. Well, a little bit, like an hour. Hopefully it goes quick. I wonder if Paul's notes talks about complex variables, because that might be a simpler. Oh, I don't think it does. No, there's no way. It's gonna be rough. Yeah. Let me. Oh, it's the weekend too. Yeah. Differential equations. There should be a good resource that explains it, maybe from scratch. That's going to be a little bit too technical, I think. I shouldn't, complex variables, second order. Are you modern Einstein? No. You ask whatever question you want, by the way, I don't care. Dude, I swear, I'm like, I feel like the least qualified person most of the time. With people come and chat, and there's like a small niche of other people who do similar like math streams. Oh, then it feels like Chinese to me. There's plenty of things in math that look like Chinese to me too. More things than not. Damn it, why? Surely someone goes over. Hey, Point Gallus. How's it going? Imagine having to write a 15 to 20 page paper on Euler's identity. Oh my god, please just get to the chase. Okay. Now please go over it. Where are the complex variables coming in? I don't see any complex variables in here. So earlier, Elias, which I'm probably pronouncing wrong, is writing a 15 to 20 page paper on Euler's identity and wanted suggestions for topics to cover. They already are saying complex numbers in Fourier analysis. My idea was to mention solutions to differential equations. And so from this electricity magnetism textbook, I have this, but I think it's probably not the best explanation of how you use complex variables to solve a differential equation. And so I'm looking for a different source that explains it. Hopefully in a bit more detail, because this book is it's kind of brief in how it explains it. It kind of expects you to be able to figure out the details. Thank you, Zach. Oh yeah, we did hit 1100. That's because I got two big raids yesterday when I was playing DayZ. Wait, top times cosine? What the hell? And bottom times cosine? Oh, I guess of these fractions. That's okay. Surely. Wait. Okay. Like I are they ever going to go over the start of this PDF was all about complex variables, and they seem to have forgotten about them now. You know what? I could send it. I do have a differential equations textbook in my files. That might be better than the E&M book. Give me a second to try and find it. Textbooks. Oh no. Here it is. Voice into Prima. This is the book that I used during my degree. This is, I mean, it's a more modern edition of it, but I assume this book goes over complex variables. I never learned this part of my undergrad, but I had to learn it so I could tutor someone in the, to be honest. Series solutions. Oh, do they not do it? Oh, I might want to look at the PDE part. That could be cool. They seriously don't go over complex variables. That's annoying. That's why I want to relearn what convolution integrals are. Yeah, I probably need to look in like an engineering textbook or something. Hmm. So I don't know if you are still here, Elias. I could try to explain it to you verbally here, and I could also give you the PDF of this textbook. I'm having a hard time finding a standalone resource that explains it, though. And I feel like if you're writing a paper, you want something to cite, which is why I was hoping for an actual resource. Yeah, so that's what I was saying. Like I can verbally explain how it works, but for the purpose of writing a paper, like I imagine they want something they can actually like a resource they can cite. They might need to do a bibliography or something. Maybe would a complex variables book have that? I I do have a PDF of this book that I've seen Zach recommend. This could have it. Let's give me the table of contents, please. This might be the best thing to look at, to be honest. If they do go differential equations, at least. Hey, my engineer study vlog. I do remember you. How's it going? Degrees of crushing. That sounds funny. I feel like this is getting at it. E prime equals E. Celestial mechanics. Oh, that makes me want to read this book even more now. Non-Euclidean geometry? Not new. Oh, really? Complex integration. Damn it. There's so many books that I want to read. Flows. Oh my god, dude. This book actually has a lot of things that I'd be interested in learning about. Let's just look at this E prime equals E bit. It doesn't have links. 5.8 though is what we want. Oh wait, are they using prime as a derivative? That this prime could mean something else. No, I think this is the differential equation. Oh, that's all they talk about though? Okay. I had to say that about chess in chat. About chess? I think we were talking about chess at some point, right? I don't remember very well though. Okay, yeah, I'm sorry, Elise. I don't have a very good written down explanation. I bet it's in an engineering textbook. Or even like, I bet another physics textbook would also explain it more. But unless I guess here's. I mean, is there anything else that we can suggest besides differential equations? I bet if you just look through this book enough, you'd find plenty of things. You watch a lot of chess streams. Oh, nice. I watch a lot of Hikaru's like YouTube recaps, and I'll watch like the chess 24 stream when there's like an exciting tournament happening. I think I don't know how you pronounce it. Veek on Z is happening, or like it just started. It could be at least I'm gonna leave your question then unless you ask anything else. I'd love to think of more things, but I'm not sure. If you want a PDF of anything that I've just shown, let me know. I might have to put it onto Google Drive if it's too big, but I can do that. Tata Steel. Oh, are those? I thought those were different things. To be honest, I didn't realize those are the same tournament. Like I think Tata Steel is the sponsor, and Vic on Z is the place. Okay. You know, I just saw Hikaru's recap of Gukesh versus Giri. That was a crazy game. This thing is almost what I want, but still not quite. Am I doing something wrong here? Hmm. Wait, I think it's not quite. I did the same sub without thinking that a squared t squared is v sub f squared. I think that's not necessarily true now, though, right? That's probably where I went wrong. I think it should be now. Vf equals v plus at, right? So a squared t squared, I guess would actually be vf minus v squared, which is weird, but hopefully it'll work out. And this at will be vf minus v. So mv vf minus v plus a half m vf minus v squared. Let's multiply this out and cross our fingers. mv vf minus mv squared plus a half m vf squared minus mv vf plus a half mv squared. What happens here? We get a half mvf squared. That's good. The mvvfs do cancel, thank God. And we have a minus mv squared plus a half mv squared, which is perfect. Minus a half mv squared. Okay, there we go. I just made a bad sub at one point. Oh, shoot. Frickin' Journal++. Or it's probably OBS's fault, to be honest. There we go. All right, let's check the answer. That was 5.4. Work field equals force times distance, ma times 1/2 at squared. What did I do? Oh, I did an actual integral, I guess, but it comes out to be the same thing. I did some extra work. And that is the whole theme of the problem, so. Okay, I think we're good for part A. Let's look at part B. Oops. From standard 1D kinematics, the distance traveled in the reference frame where the object starts with speed v is d equals vt plus 1/2 at squared. Slow f equals ma. Sorted in this frame is that, and so that's what I did do that, but with an integral. Oh, so they work backwards. But they get the same result. Okay. Note that W and delta K are larger. Wait, note that W and delta K in this frame are larger than W and delta K in the original frame. Yeah, shouldn't have been less work? Or no? No, I guess it would be more work because you're accelerating to a faster speed than otherwise. Okay. So we got number 5. So we lift a book up a height h at constant speeds. There's no change in kinetic energy. The general work energy theorem 5.6 takes a different form depending on what you pick as your system, because your choice of system depends which forces are external and thereby do work, and which changes in energy are internal. The general work energy theorem. Let's just look at that again. Is this thing here. Work equals delta E total equals delta K plus delta E internal. Um, so I think for part A, oh god. Oh. So we're kind of given that delta K is 0. What's the difference between thinking about different systems? I assume for part A, it's just going to be... I assume delta E total will equal 0 for delta K plus mgh. Because the book is internal to the system, but then how is the book plus the Earth different? In the case of part A, only the book is the system. It's being acted on by 2 external forces. One of them is gravity, One of them is me. Wait. If the system is... If the system is just the book, are we doing zero work? Because I feel like it might be. Because the work done by the Earth is equal and opposite to the work done by me. Does that make sense? So, I mean, by that logic, both A and C are both going to end up being zero. And B is going to be the MGH that we all know and love. I feel like that kind of makes sense. Because because you kind of, I guess maybe need that asymmetry of what's in the system versus out of the system, right? Like, I'm setting up the system and then I'm leaving it alone. Hey, Bode, how's it going? Doing some competition prep? Oh, nice. I'm doing good too. I'm just starting a new chapter in the physics book here on energy. Hey, Bruce Yang, how's it going? Does this feel right? It feels right to me. Maybe we'll check the answer. Right, that was number 5? Okay. I don't know why I'm so tired. Oh, I think I did this wrong. I have it backwards? That's what I thought would be for the part C. I guess I got part B right. Oh wait, maybe I did get C right. In order to lift the book, you have to burn some calories from the breakfast you ate. Oh my god. And we're actually doing math with that? Okay. An amount eta of energy in the form of heat. the general work energy theorem. What is my potential energy decrease? It would be so helpful if you go over some ACT math. Any last 10 questions? I've never done ACT. I never took the ACT myself. I could look at it though. Do they post the questions publicly, Nocturnal? They do. You can do PDFs and all. How many questions are here? 12? You want to look at the last one? Okay. Yeah, sure. We can go through these. Did I resolve? Did I? I didn't get to the bottom of reading through this answer. I'll do it another time though. Okay, let's look at number one. So Ms. Hernandez, my mistake, began her math class by saying, I'm thinking of 5 numbers such that their mean is equal to their median. If 4 of the numbers are 14, 8, 16, and 14, what is the 5th number? Okay, let's take screenshots of these and port them over. Readings from London. Oh, nice, Bruce. Thank you for tuning in. All right, so when we're dealing with median, we need this to be in numerical order. So let's go from smallest to biggest here. And I'm going to leave spaces between them because we're going to need to fill in a 5th number somewhere. 8, 14, 14, and 16. Okay. Interesting. So first off, just in case you don't know how to get the median, if we have 5 numbers, the median is the number in the middle when you put them in order. So in this case, where I wrote 13 as an example, 14 is the one in the middle. That's what the median would be. I think this one, like, since you're given answers here, I feel like the best strategy is to guess and check, to be honest. I bet there's a way you could actually set up an equation and solve it. I'm messing around with my head, but I'm not really seeing it. It's an interesting set of solutions to be given. If it's 13, the median is 14. So what's the average? 8, 13, 14, 14, 16 divided by 5. 21, 35, 49, 55. So that's 11. Really? I thought it would be 13, to be honest, just by looking at it. So here we get 11 for the average, but the median is 14, so that's a no-go. if we have 14 as the average, I think we can kind of throw it right out because it's going to be the same exact math. We're going to get 56 over 5, and that's definitely not the median. If we have 15... Really? I think it's going to be 18, and that's because I'm kind of noticing here that for each answer we go down, we're just adding 1 to the numerator. So we start with 55 for 13. The numerator for the next one will be 56, then 57, then 58. Oh wait, that's 59? That's not good. I thought it was going to be 60. What? How? I feel like I should be solving this way quicker than I am. Oh wait, no, I'm right. And they skipped 17. Oh my god. Those sneaky sneaks. That's 58. And then we skip 17 and go to 60. And so then at the end here, we get 60 divided by 5. That... Oh no, that's 12. What? Levy, hey, Pen! Thank you so much. Welcome in, everyone. Hey, Penbucks. We just had Knack Turtle over in the YouTube chat ask us to review some ACT math questions, and I'm already struggling for some reason. So I just pasted in number 1 from examples that I found online here. Hey, Pen. How's your stream? You were doing, oh my god, I had in my head what you're doing, and then I forgot, but I hope it went well. Hey, Rex. And Lovey, I'm doing well. How about you? Okay, maybe we can do this backwards. So I'm also noticing no matter where you want to place a number here in any of these blank spots, our median is always 14, right? So I think maybe a better approach is to forget all this and set up instead the equation 8 plus 14 plus 14 plus 16 plus some number x we need to solve for divided by 5 is equal to 14. So I think the median is just always 14, right? Yeah. And so let's try solving this equation and seeing what happens. So I don't know why this thing over here wasn't working. My calculations to the right were wrong before I erased them. I would believe that, Pygmy. I probably did make a mistake somewhere. 8 plus 14 is 22. Oh, yeah, I think I made a mistake. Yeah. Well, did I? I don't know. It's too late now. 8 plus 14 is 22. 22 plus 14 is 36. 36 plus 16 is 52. I hope. Over 5 equals 14. No? 24? No. 8 plus 14? 10 plus 14 is 24. Or am I misinterpreting what you're saying? I'm going to actually use a calculator here because I'm feeling a little tired today and not at my sharpest. 8, 14, 14, 16. 8, 14, 14, plus 16. Oh, I said 16 at the end. Wait, is it seriously 53? Did I say it was 52? I said it was 52. Oh, that's because I... It's 52. Okay. Okay. Quick question, because I'm watching a video about a mechanical engineer versus a 5th grade Asian student top of his class. What is a perimeter? For any shape, the perimeter is the sum of the lengths to the side. If you have a rectangle with side lengths 2 and 5, you add up all the sides. So 5 plus 5 plus 2 plus 2 is 14. That's what the perimeter is. I don't know if I might take offense to you calling it a calculator. What it calculates things, therefore it's a calculator. 2 pi r, yeah, that's like, you call it the circumference for a circle, but the circumference of a circle is basically the perimeter, yeah. It calculates the same thing. I don't know why we use a different word for circumference, but you could think of it as the perimeter of a circle, yeah. What else use the perimeter of a square? Okay. Yeah, for anything with straight sides, you just added the lengths of all the sides. Okay, so coming back to this problem, 5 times 14, that should be 70. Because 5 times 12 is 60. Subtract 52 over... Okay, it is 18. I'm not crazy. Okay, so for number 1, I'm saying E. Let's pull in number 2. We're off to a great start here, by the way, guys. I definitely have a degree in math, and I'm not making that up. Oh my god. This next one has so many graphs. I'm gonna need to do this in multiple screenshots, I think. It's 2 length plus 2 base if you have a rectangle. It depends on the shape. A circle has infinite sides, the perimeter is infinity. True. That girl, she's talking about integrals. Oh, nice. That's like calculus. Number 2. The graph of a certain hyperbola y equals h of x is shown in the standard xy coordinate plane below. Among the following graphs, which best represents y equals minus hx? Okay, so this is like a function transformation question. If you take a function, let's just pretend we have a simpler function, like if we have y equals x squared plus 2x plus 1. It's a parabola, well, plus 3. It's a parabola that's something like that. If you take this entire function and just stick a negative sign in front of it, like they're saying to do, what you do is you vertically flip it. So you get a parabola that looks like this. And that vertical flip is the same for any function you want. So we want to take this graph and flip it vertically. See which one matches that. F looks like a good contender. G, that's a horizontal flip. H, they flipped half of it, which is certainly not right. I, they flipped it and erased half. J, they flipped it and erased half. They didn't even... No, J, they just erased half. Okay, yeah, these options are super weird. The answer is F. Now my math instinct tells me there's a way to set the function about that, or like number for a certain shape. Is there a way? The perimeter... So I think the math way of saying that is the perimeter of an n-sided polygon. And I'm certain there's a formula for that. Is that Heron's formula? You probably need to make it a regular polygon. Or maybe not. Okay, yeah, if it's a regular polygon. Go away. Wait. Talk about the area of a function? Oh. Here, let me... Oh, number 3 is another big one. It just scrolls the exact wrong amount. Oh. Hello, Zach's kid. Hi. um okay, so before I get to number 3, Lucas, you're asking the area of a function. So that's what the integral is. If you learn about it in calculus class, if you have whatever random function you want, let's call it f of x, you can get the area under a part of that curve. So like if you want the area between these 2 points, let's say that's x equals a and that's x equals b, you would say that green area is that's the integral from a to b of f of x dx. And you can actually, if you're given a function in a and a b, you can actually get a number for that area. What is d? It's a whole calculus thing that would take a little bit too long to explain. The short version of the idea is that depends on the girl, I guess, but the short version is that you start with approximating the area under the curve using rectangles. So I can draw a rectangle like that, a rectangle like that, a rectangle like that, a rectangle like that, and I can add up those areas and say it's an approximation for the area under the curve. And then the magic of calculus, you make those rectangles thinner and thinner. So like instead of doing 4 rectangles, I can do 8 rectangles that are half as wide. And if you keep doing that infinitely many times, you get the exact area. And the width of those rectangles is dx. That sounds hella boring. Well, then I'm going back to these problems then. Calculus is my favorite. I thought calculus was boring until I took I thought math was boring until I took a calculus class. Okay, we need to see this diagram a bit better. In the figure below, angle H is equal to angle F. E, G, and I are collinear, and G is the midpoint of FH. To prove that... Oh, hey. Hello, line segment. To prove that HI equals FE, given the conditions stated above, which of the following is a logical order for the 5 steps in the table below? Ooh. Okay. So at least they give you the proof. Oh, so the statements are all out of order. We have to choose the right order. Okay. So statement 1, HG is equal to FG. The midpoint, okay. That seems like something you can say pretty early. Angle EGF is equal to IGH, right? Vertical angles. Triangle GHI is similar to, GFE. That, they want angle side angle congruence. So we definitely can't put that one up front. Angle EGF and angle IGH are vertical. EGF, IGH. Oh, okay. So a tentative order, 4 builds into 2, and 1 can go seemingly on either side of it. We can say builds into 1, builds into 3. Angle side angle. What other angle is it? Oh, we're given the other angles the same. And then it's going to build into 5. I feel like 1 could also go at the start, though. That part is flexible. But I think that's the logical order. Like, you definitely end with 5, because that's the thing that we want to prove. That hello equals iron. HI equals Fe. Lucas, the idea of the question is they've given you a proof, but they've scrambled all the steps. So you have to find the right order. So I'm saying you start with step 4, go to step 2, go to step 1, then 3, then 5. But 1 could also come first. 1 has to, okay, well, all the options involve starting with 1. So we're going to put 1 at the front. So 1, 4, 2, 3, 5, that looks like D. Bring up number 4. English is way too confusing. It is a weird language. I hate learning new words. Is that bad? I mean, I feel the same way about like trying to learn Spanish. I like learning the grammar. I hate learning the vocabulary. Each of the variables t, w, x, y, and z represents a different positive real number. Given the equations below, which of the 4 variables w, x, y, and z necessarily has the greatest value? Different positive real number. That's kind of a funny question. So the way I think of this question, I think the answer is going to be Z. Yeah, and Rex is saying the same thing. And the reason that it's going to be the last one is, let's start by looking at the first one. These are all equal to the same like number. So if you have to take W and multiply it by 1.23, that's like you're increasing W just to get up to T. Because 1.23 increases. So W must be less than T. The same exact logic with X, where 1.01 means we have to increase X just to get to T. So we can also say that X must be less than T. And further, like, I think because you have to increase W more, 1.23 is a bigger amount to increase it by, you could even say W is less than X. Now coming over to Y and Z, 0.99 times Y means you have to decrease Y. Y is more than T in this case. Just a little bit more. And sorry, maybe I should have started with if you had just a 1 here, say 1 times u equals t, that means u and t are the exact same thing. So the farther away you are from 1, the more you're changing u, or the more like you have to change u in order to get t. So if you're very close to 1, like with 1.01 or 0.99, you're nearly equal to t, but not quite. If you have a million times a number v equals t, v is very far away. So that's kind of like the scale that we're using here. So finally, 0.23z equals t. This means we have to decrease z in order to make it equal to t, so you know z is more than t. And because 0.23 is farther away from 1, we know that z is more than y. Does infinity plus 1 exist? It's still infinity. If you take something infinitely big and add 1 to it, you haven't actually changed it. So that's the logic for number 4 there. And sorry, for anyone who isn't an American, these questions are from the ACT. And the ACT is like a university entrance exam that you take when you're probably about 17 years old. I never took it because we have a different one called the SAT that I did take. But that's kind of like the level of questions that we're looking at right now. Infinity minus 1 is still infinity. You can add or subtract as much as you want from infinity, and it's still infinity. Except for infinity itself. Well, okay, you're getting into the whole thing, Lucas. Like, infinity plus infinity is still infinity. Infinity minus infinity is who the hell knows. It's called an indeterminate form. It's not. Infinity has weird rules. We say we just don't know what it is. We can't determine what it is. It's indeterminate. It's a contradiction. If you have something that's infinitely big, it should be impossible to reduce it to 0. But if you subtract infinity, then, you know, who knows? Infinity isn't closed under additive inverse. I have no clue, Jed. Probably not. I think you're getting into like an algebra discussion of the extended reals, which is what Zach is talking about. I think like R bar is how it's normally denoted. But yeah, if you have the real numbers union infinity, whatever that means, that's the extended reals. And people do like study that thing and do things with it. I don't know anything about it though. It's the black hole of numbers. Yeah. Does I infinity count as infinity? Like I complex number I? Infinity plus infinity minus infinity is not equal to infinity plus infinity minus infinity. If you have infinity minus infinity equals 0, infinity plus infinity equals... Whoa. Huh. That's weird, Phobos. You also need minus infinity? Oh, I didn't even know that. Okay. So you're asking about like complex infinity? Okay, and this is gonna be like I'm getting back to the ACT thing for Nocturnal in a second here. There is a concept of infinity for complex numbers. It's not that simple though. For complex numbers, we have to represent them as okay. A complex number is like 2 plus 3i. You have a real part and an imaginary part. And so we often graph these with a real axis and an imaginary axis. So 2 plus 3i would be 2 to the right and 3 up. So right there. If you have a complex number, wait. Root of, so I is equal to the negative square root of 1. All right, see ya, Oliver. Have fun. That could have been worse. So you got through it decently quick. Yeah. Thanks for hanging out. So I is the square root of negative 1. If you have I times infinity, I'm not quite clear on what that would mean. You could say it's a point maybe somewhere super far up the imaginary axis. But usually with complex numbers, you kind of talk about the distance from the origin. So the origin is right there. And in infinitely big complex numbers, I think in a lot of cases, you just think of any number that's super far away. It's like some super far away circle or something of complex numbers. What would be the root of minus infinity? I don't know. I think it probably... I think you could say the square root of infinity is still infinity. So maybe you could say that's I times infinity. I bet you just say it's indeterminate though or something. Infinity plays by weird rules, and you're really stretching the limits of my knowledge here. Reddit has a discussion about this? Oh, of course it does. All right, I'd look at that thread then, I guess, Lucas. Isolate the -1. Oh, I'm sorry, I just erased it. I don't know how you would isolate it, or I'm not sure what that would mean. 11 years ago? Are you saying like it's not going to be out of date? That math isn't changing anytime soon. And number 5, I think all they're doing is getting a common denominator here. 5 over k plus 3 over k plus 5. If we get a common denominator, we take this one and we multiply it by that denominator. So 5 over k times k plus 5 over k plus 5. And then we take this one and we multiply it by this denominator. So k plus 3 over k plus 5 times k over k. What we get for the first fraction, we multiply across the top, multiply across the bottom. 5 times k plus 5 over k times k plus 5 plus, now the second fraction we do the same thing, k times k plus 3. Oh god, that's a terrible 3. Over k, oops, times k plus 5. Now they have the same denominator, so we can combine them into one big fraction. 5k plus 5 plus k plus 3 over k plus 5. They do, Lucas, yeah. Okay, so I can see we have a k plus 5 on the bottom, and we have k plus 5 on the bottom for 3 of these answers. So we can already knock 2 of them off. Let's distribute out the top. So 5k plus 25 plus k squared plus 3k over k plus 5. Now just combine common terms. K squared plus 8k plus 25 over k plus 5. And please tell me that an answer matches. Oh my god. Okay, good. I didn't see answer E. I thought I did it wrong again. Okay. That one is a bit more straightforward if you know to get the common denominator. The wrong number after 3 hours works. He said root 9 is 9. Oh no, that sucks. 2x2 matrix below B1 and B2 are the cost per pound of bok choy at market 1 and market 2 respectively. Bok choy is pretty good. R1 and R2 are the cost per pound of rice flour at these two markets respectively. Yeah, I don't think I've seen any bok choy based math questions before, but I think we need more of them. Teacher cut 3 points off. Oh, that sucks. I think pak choy and bok choy are the same, aren't they? Or it's just like a different like English spelling for a Chinese word. I feel like they're both right. I don't know though. In the following matrix product, what does Q represent? Oh, it's one of these. B1 and B2 are the cost per pound of bok choy. What does Q represent? I need to do this matrix multiplication now, because I this economic stuff I don't remember the intuition for. But wait, Nectaral, are you still here? I haven't seen you say anything in a little bit. Okay, so you take this column multiplied onto that row, right? Wait, so this is, I should 1 row by 2 columns, 2 by 2. We're gonna get 1 by 2 answer. Oh, of Doug is equal to PQ. So we're gonna get 0.5 B1 plus 0.5 B2 for the first entry. The second entry, that is Q, is 0.5 R1 plus 0.5 R2, which is only slightly helpful. What are the answers? They don't explain the 0.5 at all, which I kind of hate. So R1 and R2, so like this one over here is Q. It doesn't involve B at all. So we don't expect anything involving bok choy, I don't think. It should only involve rice flour. The cost of R1 pounds of rice flour at 50 cents per pound. But R1 is already the price per pound. If you're multiplying by 0.5, you're cutting it in half. Oh, hi. Okay, I guess that's G then. No, but it's not just a market 1. This one involves bok choy, so it's out. This one doesn't involve market 2, so it's out. This one just doesn't make sense, so it's out. The total cost of a half pound of bok choy and a half pound of rice flour at market 2, that's out. The total cost of a half pound of rice flour market 1 and a half pound of rice flour market 2. Okay, so it's J. That's a very odd question. I'm not saying... Nocturnal, you still haven't typed? I don't know if I'm going to go through all these if you just failed. What makes it difficult numbers and make imaginary numbers called I and not just 3 minus or something? I do kind of wonder why we use I for that, rather than just keeping it as like the root of -1. I assume there's a historical reason, but I don't know if it's always like the best notation. I mean, it's more convenient to write, but I feel like uh, it makes you forget what it actually means, I guess. Okay, I haven't seen Nectarol type anything in a minute. I'm just gonna bail on these ACT questions then, because I'd rather do physics if Nectarol's in here. I'll keep it up in case they say something, but so we use logs instead of root x. A logarithm is a different thing from a root. Are you saying that 2 to the x equals like log base 2 of x or something like that? This is not right. I'm confused by what you said. Or I guess you're saying a root. It's like, I don't know, like 1 over x. It still doesn't really. Or rather, like this. Like this isn't right either. You can relate them, but oh, wait, okay. If you have 2 to the x equals 3, then 2 equals root of x's power 3. I don't get what you're saying. The way that you would translate this into log is that 2 to the x equals 3 is the same thing as log base 2 of 3 equals x. But you're saying we should write it instead as, oh, 2 equals the x root of 3? I say, and you're saying that the logs are better because they're easier to work with than a root. Yeah, no, I agree with that. Okay, then I think I understand what you're saying. Yeah, because the x root of 3 is ridiculous. I wouldn't want to do anything with that if I don't have to. I was looking through the answer to this one. And in part C, they pull a real switcheroo on you. What is minus I? It's just minus I. There's nothing wrong with having negative I. It's just a number like 2i. Imaginary number like 2i, I guess. To me, you have minus I. Well, then you have I times I, and you can make that equal to -1. And so, you mean something else, okay? The root of minus I? Yeah, you can do that. you need to learn the exponential representation of a complex number, but you do just get a different complex number if you take the root of negative I. Negative I is not just one, no. If I is the root of negative 1, then negative I is the negative root of negative 1. If you want, you can take the square root of negative I. You just get some other, I don't remember like exactly what it is, but it's going to be something weird like root 2 over 2 minus root 2 over 2i or something like that, I bet. I don't know exactly what it's going to be, but it's going to be something funky looking like that. Yeah, as you're saying, it's a whole like rabbit hole. What the? Did Firefox just update on me? I just went to go back in my Firefox tab. I got a Windows pop-up asking if Firefox can make changes to my device. I don't know. I just hit yes. Doesn't everyone just hit yes on those things? Oh, my potential energy decreases because I burned calories lifting the book? Bruh. If it probably didn't update on you, it's software not made of physical matter, dumbass. Does physical matter have updates? I hope it doesn't. If so, I'm behind on my updates. I find that side of math way more interesting than integrals. Honestly, me too. I mean, complex variables is a whole thing that you can go into. Penn Center taught a whole class on it on Twitch. It also, you can relate it to integration. There's apparently a really cool crossover that I haven't studied. But yeah, see? Isn't every number... Yeah, I mean, you could think of every number as an imaginary number. But yeah, like Penn Center is the one out of all us who loves complex variables the most, I think. So I only have like a kind of passing understanding of it, but like everyone was actually quite true. Yeah, if you want to get even crazier. Oh yeah, drink that water. You like that? I'm curious. Are the materials from the complex variables still up? Oh, they're not. Oh well. You're a quaternion. Um, it's straight vodka. You know it. But I should have access. Oh, I didn't see them. Maybe I just had a tab collapsed. But yeah, Lucas, if you want to learn more about complex variables, I have at least one PDF of a textbook that I could send you. It might just be me. Oh wait, is it in that tab? No, I don't know. But either way, if you're interested legitimately to learn more about complex variables, I can give you some textbooks, if nothing else. I didn't see it when I quickly looked in the elements, but I don't know. I'm going quick. If you lead a channel that has people in there, do you eat the people too? I think so, Central. Gotta remember to remove the people first. If you get deleted in Discord, you get deleted in real life. Including an amount eta of energy in the form of heat that your body generates by lifting the book up. Better yet, Shark, thank you for the follow. The people become imaginary. There we go. But you don't delete anything, you just remove computer's path to the file so they get stuck there forever unless recovered. No, I think you actually, when you hit delete on a file, it does delete the actual data. Like, I mean, it goes into the recycle bin and then it gets deleted. But that's the entire reason you need to defrag your hard drive, unless you have a solid state drive, in which case it's apparently a bad idea. But that's the entire point of defragging, because you get like gaps between files as you delete things and install new things. You can get rid of those gaps. It's an episode of Doctor Who? That sounds like an episode of Doctor Who. Your potential energy decreases by more than mgh, but heat is produced. The sum of these two changes in energy, decreasing your potential energy plus the increase in heat, equals minus mgh. What? Oh, okay, yeah. This is ridiculous. Okay. Oh, it leaves it to be rewritten. Okay, fine. I guess so, yeah. Yeah, I guess there's no point in overwriting it with garbage data or something. You thought all potential energy is all gravitational, and now this? Well, okay, they're accounting for the calories from the breakfast you ate that you burn as you lift the book up. Like, and then it cancels out with the heat your body produces. You have potential energy. Oh, no, I was saying you only have. You were saying you have potential energy just by having mass. But you'd have to have. Okay. Well, that's not what elastic potential is. That's when you stretch a rubber band. Like, unless you're being stretched, I guess, then you would have elastic potential. It was part of the joke. Well, no, I mean, you would need to. Okay, you know, that's like it's like my cheek only has elastic potential if I pinch it, you know? That has elastic potential now, but this one is resting state, it doesn't. You're a joke? Okay, fine. You know, let's just really explain every joke to death. The food was stretching me. I mean, I guess. I was imagining elastic like an elastic waistband, I guess. I don't know. Like I'm imagining like yeah, I guess like the waistband on your clothes is definitely getting a lot of like potential energy, elastic potential energy. Okay, let's move on to number 6. And that's the last foundational one? Okay, that's the last foundational one. So once you do 6, we'll go back to the multiple choice. Thinking about the atoms and molecules is actually electrostatic too, with a charged particle. They cancel each other out though. Are you saying that if you eat more, you have more potential energy because you have more particles making electric fields? I'll cancel you. You know what? It takes a canceled person to know a canceled person. Get in my electrical field. Hey, Divyansh. I'll rip you from your atom. Which one of my atoms? Every one of them are precious to me. Actually, if you're ripping me from my atoms, that means you're taking like almost all of my body minus an atom? I don't know, dude. Mass spring with constant K hangs vertically from a ceiling initially at its relaxed length, and mass M is then attached to the bottom and released. I'm calling you an electron, which also doesn't make sense. Oh, I get it. Okay, well, I'm glad it also. I'm glad you said it also doesn't make sense. I get it now with the electric field, like tearing electrons off or whatever. The total potential energy, gravitational and spring of the system, is a function of the height y, which is a negative relative to the initial position. Okay. Gotta go and be a legend elsewhere? Well, don't lie to me, but see ya. You're a shit spring. Spicy. That's basically 90% of what me and Central say to each other. It's just insults. Good bounce back. Thank you. Instead of, oh my god. Go pretend to be a legend. That joke was too compressed. Oh my god. You are the actual worst. Don't ban me, force me out. Or ban me, force me out. Yeah, it's like I'm gonna have to start dropping the hammer. Force me out? Alright, fine. He asked for it. I just did a timeout though, because I'm gonna forget to unban him. Which I mean, maybe that'd be for the better if I forgot to unban him. um. He messaged me on Discord saying naughty. My god. Do a minesweeper? Okay. It's time. Minesweeper. Oh, this is just RNG here. It could be any of these. Just go for that one. Hey, okay, we got lucky. Ah, this is RNG also. So that one? Ah, okay. Your point total says so, yeah. Oh, I just misclicked on that bomb. I had a good streak going of not failing. The last few Minesweepers people have redeemed. There we go. 34. That might be one of my best ones. Oh, people are doing intermediates in 20 seconds though. That's crazy. What about all time? 9? Wow. People do beginner in 1 second somehow? How big is beginner? Okay, 1 second? That's not possible. You can't even click that fast. That has to be like a bot or something. The hell? I don't know. This person, Camille Moransky, has cleaned up the leaderboard. In 2013, these scores are from. Wow. I feel like this leaderboard, there's only no one's beaten it since 2013, or no one uses this website. I don't know. Hey Clunk, thanks for lurking. Hope you're doing well. Oh god, my wrist just cracked. I don't know if I might pick that up. That was like a weirdly loud crack. You did hear that? Oh my god. My wrist kind of hurts now. That crack was too good. The 1 second speedrun time is RNG? Oh. That's ridiculous. You just keep doing new games until you get the perfect one that solves it for you. You don't have to hit a single thing. Okay, if anyone's having trouble with Minesweeper, just put it on the easiest mode and keep cycling it until it solves it for you. Oh my god, you just need the perfect arrangement of initial bombs. It's hilarious. Imagine going for those speedruns. No skill percent? True. That's my speedrun category, no skill percent. I haven't watched speedruns in a long time. I used to watch a lot of Dark Souls speedruns. But I feel like the heyday of that has kind of passed, at least since I was watching. But I've seen some Portal speedruns and some like I think Zelda speedruns too. Those videos aren't fun anymore, like Ocarina of Time if you allow for the 5-minute warp. Yeah, exactly. Like a lot of any percent speedruns, they take an insane amount of skill. Or like, I mean, I assume that they do. Maybe some of them don't. Like you have to do a ton of research to find like the glitches that you use, but they're not particularly entertaining because you're just out of the map most of the time and doing super weird, strange looking things. The Dark Souls speedrunner I would watch would always do all bosses. And there are some kind of funny glitches that you can do in Souls game to really speed it up, but the fact that he had to do all bosses meant like the speedrun was actually like, 2 or 3 hours, and it was a lot more like entertaining. Any tips on how to just start school? Because sometimes it takes a little too much effort. Like how to get to school? Like getting the motivation? Can you do Sudoku? Well, I only know the very basic, like Sudoku solving algorithm. I think there's like a better one that works on harder Sudokus that you need that I don't know. I know Fembox likes Sudokus a lot. And there's a streamer, Mango's Princess, who likes Sudokus in all their like variants. But yeah, I'm not super into them. I think it does get deep. I don't really know the extent of it. Like starting homework, Lucas. I mean, for me, just promise yourself you're gonna do like 15 minutes or 20 minutes or 30 minutes of work, whatever the right amount of length is for you, and then take a break and just set small goals. Like that are more achievable. Oh, you know what? Oh man, I follow a person who actually solves Sudokus on stream though, because Mango's, I don't think she does. I don't think she usually solves Sudokus on her stream. But there's another one who I can't remember his name, who I've actually found from a raid who like solves Sudokus on a stream. I don't remember his name though. Oh well. I don't think I see him streaming very often anyway. A lot of, I don't know. I guess crossword solvers make sense. I've never seen a crossword solving stream, but it makes sense that people would do it. or would like stream that. That could be kind of cool to watch. Is this in depression does crosswords? Oh, I haven't seen him do one. I could definitely see him enjoying crosswords. Suna. Thank you for the raid, Suna. Welcome in, everyone. Just talking about Sudoku and crossword puzzles and doing some physics studying. How's your stream, though? What were you up to? Total potential energy U of the system, gravitational and spring, as a function of height y, which is negative. Okay, so I think spring potential energy, well, I'm only gonna think, maybe I only think about the scenario as they showed it, where you have the spring with no mass at rest, and then you attach a mass and it comes down. I'm not going to think about any oscillations after that, maybe. And in that case, as the spring as the string stretches out, it gets more potential energy, but it loses gravitational potential energy. So how do we feel about 1/2 ky squared minus mgy, something like that? There's actually a gadget to translate cat meowing to English? What? That has to be made up. You can't translate cat's meows to... Or actually, no. You can maybe the translation is food. 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 Maybe that translation I would believe, but like... Sorry for the reply laptop on was blue screened. Oh no. You're good though. Thank you so much for the raid though. How's your stream? What were you up to? At least if your laptop is like glitching out, then don't feel obligated to like type and make it work. But if you're able to, I'd love to hear about it. Just trying to understand kinetics a bit. The math slayed me once again. Nice. So yeah, for anyone who's here on my end, Suna does studying streams for all of their various classes, including math. And I've seen some like science studying on there too, of a lot of the different subjects. And then I've also seen them playing Overwatch and Osu, if you're into that. So I like that this is y squared, because anytime the spring deviates from its resting position, it's gonna have potential. And so the sign of it shouldn't matter, like positive potential, right? Just a bit hard to see what I typed because I see what I typed only 5 seconds after the fact. Oh my god. That sounds really frustrating. It sounds like it's probably your laptop's fault, but I've had Twitch kind of do that to me too. If I have a tab open with a Twitch stream for a long time, and the tab kind of gradually gets slower, and the things that I type get really laggy, and it forgets that I pressed a certain key. So that's super annoying. Um, and so we're calculating potential relative to the initial position. Oh wait, we want plus MGY. Because when the mass is below the resting point, we have negative gravitational potential energy for this reference point. And when it's above the resting position, we have positive potential energy. So I think the plus will take care of that because the y will be negative when it needs to be. Find the point at which potential energy is a minimum for part B. Kinetics is quite neat when you understand it, but not quite there yet. Yeah, fair enough. I imagine I'm gonna bet that the shape of this potential energy curve is something like a U. Because I think it's gonna have the least potential energy right at the equilibrium point. Because yeah, no, it should just be zero. Because we're defining that as our reference point. Well, it's gonna have negative. Ooh. You know what? The minimum is definitely gonna be in the lower half. Or at zero. The spring constant is a bit like in kinetics, no? I'm not sure what it's supposed to be like, but like a rate constant in both cases. I mean, I guess it's almost like an acceleration, but it's not quite, if that's what you mean. I think I might be misinterpreting you though. Wait, why do they use U in part A and V in part B? That's kind of, I hate that. Either way, let's find, I guess we'll find U prime to find the minimum. We're taking the derivative with respect to Y, right? And setting it equal to 0. Not quite, probably just that I see kinetics everywhere by now. Yeah, I mean, like for a spring, F equals, or sorry, the force of a spring is equal to Kx. And we also know that F equals ma. So there's a relationship between K and acceleration. But yeah, it's not quite so clean. It is kind of like that though, because it's like, how many newtons of force do you get per meter of spring, I think is what K is. And that is a rate in the same spirit as acceleration. So I can kind of see that. Are U and V different from me? That's just a typo. I think they say that U and V are interchangeable when they talk about potential energy. Hey, hourly dose of internet. Sometimes the letter B is used instead of U, so that's what I'm going off of. Yeah, sure. Let me know what the question is. So I don't know why they're mixing it up mid-problem, but I think they're supposed to mean the same thing. Hey, Mohammed. Do we get a negative value for y, which I think makes sense? What are the units here? My seconds aren't canceling, right? That's a problem? Oh, because they are supposed to cancel. Okay, I think the units check out then. You have 6 people, and how many ways can you arrange them in 3 boats, where the first boat has 3 places? Okay. Is this boat thing a red herring? Oh, I guess it... No, it's not. It does change things. I was wondering why we can't just treat it as a normal... How many ways can you arrange 6 objects? But we would consider... any, like, if the same people are in the same boat, we consider it the same thing. You think it's 60? Are you an introvert? Yeah, I am. I think, I feel like we need to do something with, like, this boat has 6 choose... Oh. 6 choose 3 many options. This boat has 6 choose 2 many options. This boat has 6 choose 1 many options. And we have to do something with those chooses, I think. Hey, Tyler. On YouTube and Twitch. Hell yeah. How does internet also get 60? Hope you're doing well, Tyler. Continue to look at kinetics. Sounds good, Suna. Thank you for the raid. Good luck with your kinetics. 3 choose 2? Oh, I could see it being equivalent to something like that. Well, 3 choose 2 isn't 60, right? Or what do you mean? Maybe you're talking about, like, this one should be 3 choose 2. I'm doing well too, thanks for asking. Just struggling with this, like, this should be a pretty quick question for me, but it's not. And then do we add these up? Is that the idea? Well, you just know that's one. I'm just gonna say that. You multiplied them. Oh, hell if I know. Why would you multiply them? Oh, actually, that might make sense too. Dang it, I can't explain it, but yeah, multiplying does feel right. I wish my intuition for these combination problems was better. I feel like you do multiply them. Uh, and I forget the justification for why. I mean, Muhammad, you're just gonna ask me a million questions just to annoy me. Like, I'm trying to figure out a math problem right now. That's why I'm not responding to them, because I know you're just gonna ask another one as soon as I answer it. Benbox, you're doing it in one go with 6 factorial over 3 factorial, 2 factorial, 1 factorial. Why is that? Trying to do meth here, exactly. Here's a similar question. 9 people in 3 boats. Each boat has 3 people. But my day was good though. At hourly dose of internet. Thank you for asking. How about you? Oh, okay. So that's what Fenbox did. You have 9 factorial ways to order the people, and then you divide by 3 factorial 3 times to remove the ordering of the people within each boat. Um, and so the way that you do that approach for this problem, which is what Fenbox said, is you have 6 factorial ways to arrange 6 people in general, forgetting about the boats, and then you divide out 3 factorial for the first boat, 2 factorial for the second boat, and 1 factorial for the last one. Oh, it's a shame, Mohammed. You have to stick to spamming me on just one platform, then I guess. Hmm. All right, I guess, does that make sense? Harley does. I have to explaining the why, but I think the work that you did is, it should be fine too. I just like, I don't remember how you actually justify that. All right, I don't remember how you justify the other approach. Ugh. Okay, I'm not saying the exact thing, but oh, St. Lawrence Seaway Ship Watchers Network. See, I'm sorry, I can't give a better explanation for the why of it. I'm just not that good with combination questions, but I think your answer is right. I really do. And I'm sure there's a justification for this way too. I just don't know how you give the intuitive explanation like we saw for this one. Yeah, no, I know they're both right. I just don't know how you explain the other one. So I feel like the other one is like the result of a different approach that I don't know. I feel like it's something like it's something to do with combining combinations of things, and I feel like there's a rule for that where you multiply it, but I can't remember exactly how it works. Muhammad, I don't know what chapter. I don't know if it's even from a book. We have the same amount of information here. It's just the question. I don't know. Okay, so um, unless I'm mistaken, I going back to the physics. I think we got this for our minimum energy point. Just out of curiosity, can we prove this is a minimum? I mean, I don't know, guys, where mg over k is. I guess. Uh, if y equals 0, we get mg, which is a positive amount. That's not good though. We want it to be negative if it's a minimum, right? Oh wait, no, that's good because the zero's on the right side. It's multiplication rule for multiple events. We're doing A and then B and then C. The number of ways in total is the product of the number of ways each individual. Okay, thank you, Fenbox. So that's what I was wondering. Multiplication over multiple events. That makes sense. Thank you. Um, this function is just a parabola, isn't it? Yeah, one of the zeros is at y, the other one is at where's the other zero? Interesting. Oh, that makes sense. It has to be evenly spaced. The distance from 0 to the minimum has to be the same as the distance from the minimum to the other zero. Oh my god. I need to flip that. So what does this mean? When y is positive, oh, that makes sense, I guess. The spring potential and gravity are agreeing with each other on their sign. Otherwise, they're kind of working against each other. Or no? Muhammad, that question looks way more annoying than the other one. Wait, so if y is negative, you generally get this interesting behavior where the spring potential and gravitational potential are working against each other. But if y is negative enough, it comes back around to being positive and agreeing with each other. Should we even be allowing for that scenario? Like, is spring going to break at some point? I think we don't allow for the spring breaking. What does it? Why does it become positive again at some point? What does that mean? For very negative y's. I guess because the potential energy is taking over. The spring's potential energy is taking over. The spring's potential energy becomes more positive than the gravitational potential becomes a negative, I guess. I think my graph kind of makes sense. It was like this little tail I was thinking about, but I think this tail over here kind of makes sense for more obvious reasons. So what's part C say? We write the potential energy as function of z, defined as y minus y naught. Why not? Explain why your result shows that a hanging spring can be considered to be a spring in a world without gravity. By the new equilibrium point, y naught is now called the relaxed length of the string. Ooh. I assume they mean. I assume that y naught is the relaxed strength with the mass attached. I love those bongo emotes. Oh, that's your emote. Did you make that? You made it just now? Oh, that's awesome. It looks great. Because you're gonna lose that emote? Oh, because it's someone else's. I get it. I feel that if I get gifted a sub that I like, and I find that I like their emotes, yeah, it could be a bit faster, like that one is, but it's not bad. um, yeah, I was just looking at that. Why minus why not? Yeah, So I'm curious, given the thing that I said before, making a change of variables z equals y minus y naught, wouldn't that be the same as a horizontal translation to the right of my parabola? Why would that imply that we can disregard gravity? I'm not sure what they want for part C, or I'm not sure what to do for part C. Who is that? Oh, Ivan Neo, yeah. He has a good channel. I've been following him for forever, hoping to be able to rate him, but we just stream at 2 different times. Okay, you know what? Maybe we'll verify part A and B first. Make sure I'm on track there. I can feel my brain fading. I kind of want to end on this question, but I'm not figuring this question out as quick as I like, as I would like. I did get the sign right. School philosophy stuff. I found out he knows a ton of physics too. Ooh, I didn't know that part. That's cool. Looks like I got the graph right. Relativity on Wednesday night. Ooh, that's awesome. I haven't tuned into a stream in a long time, to be fair. Okay, so I think we've done part A and B correctly. For part C. Oh. Okay, maybe what they want is that we take why not equal to here. Oh, I'm stupid. I forgot they called that point why not. Oh my god. Okay, I just don't know how to read. Next stream I'll learn how I'll stream me learning how to read. Okay, so we take our same potential energy function, and instead of ky squared, we're gonna have ky minus y naught, which I said is mg over k, negative mg over k. Learning to read from first principles? Hey Sam, what is the most challenging math problem to deal with that may have kept you up all night? I haven't had a single problem like that since the first time I took a calculus class, and understanding what a derivative is. Like that occupied my mind for a few weeks to try to get that intuitive understanding. So questions like, they'll give you really weird graphs like that and tell you to graph the derivative. Questions like that I could do by rote, but I was thinking about them a lot in terms of what they actually meant. And so I guess that's kind of the problem that I've spent the most, like the single problem I spent the most time on, I think. Once I understood that, kind of the rest of calculus fell into place for me, to be honest. Oh, you know what? We're not going to get any cancellations here. Well, let's just see what happens if we multiply this out. Having g and y in the same problem is kind of dangerous. Because they look the exact same with how I write them. Oh, the k's cancel there. Okay, Sam, I can see you sent a second message and immediately retracted it. I hope you're not expecting a response for that. Okay, what's happening here? This makes no sense. I feel like we are not disregarding gravity here. Uh, I was hoping we get some kind of cancellation or something, and it would end up looking just like the potential energy for a spring. Or we could somehow interpret the thing that I get in the last line as potential energy of just a spring. Do I need to flip the sign? Did I do this change of variables wrong? My brain's moving too slow to figure it out. I'm just gonna try flipping the sign and seeing what happens. So the MGY's cancel. And that becomes a -1/2. That makes more sense, right? Oh, Mangus. Someone was asking about like people who like Sudokus, and so you were a person who like came to mind. I didn't try any for myself though. Yeah, I should really write why like that when I'm doing a problem like this. I'm just not in the habit of it though. I was taught to write whys like that as a kid, and that's kind of how I do it. DailyKitKillerSudoku.com shout out. Oh, nice. But then if I have a gamma in the problem, we have all sorts of issues. Unless I do the other gamma, I guess. Dude, I don't know if like I was taught to write in Danilian as a kid, which is like halfway between block text and cursive. Like I made my K's like that because it's like a cursive K. I was taught, how else was I taught to write? I had to put like little squiggles on the start and end of my letters. Like that's an N. It's a crappy N. Like that is how the write ends. It's weird. But that's why I write my Y's the way that I do. I either wrote Y's like that or like that. I don't remember, to be honest. Matthew used to do 2 O's for infinity until I had his class shame him. Oh no. That looks terrible. That's the worst infinity I've seen in my life. I think for part C, the justification for disregarding gravity is that this is just a constant and not all that important. We're way more interested in how the variable part is changing. But I don't know. When a student came to the tutoring lab, I'd ask if he still did and tell him to bully him about it. Nice, yeah. That does deserve some bullying. You do flip the sign, and that's justification for why. Okay. Oh, what? What? Excuse me? I don't know how I did that. Anyway, still showing up again on the stream. And I get, I did it, I shouldn't have reused Y, but who cares? Right, only difference in potential energy matter. Nice. Former math tutor, teacher, grad student. Yeah. So for anyone who doesn't know, I know Mango's likes abstract algebra the most. Or I say that's what I remember at least. Sounds good. Thanks for saying hi, Mangoes. Even those parts except I still tutor. Oh, nice. Honestly, I think I'm going to wrap it up here too. I get my brain is moving at the speed of a especially slow snail. So yeah, I'm gonna cut the YouTube stream off here, and then we'll look for raid over on Twitch. So I know it's here on YouTube. Thanks for being here.